Okay.
All right. Hi, everyone. Welcome to this career panel on machine learning. My name is Tabitha Kavu, and with me here I have Kawalat um, and Ola Yinka. I don't know if I can call him Yinka.
Yeah, that's
Kawalat
fine.
is a machine learning advocate, and Yinka is a Google developer expert in machine learning. And I mean, we have the best of the best, and we are truly honored to have you guys here, and really hope that by the end of the session we'll be able to like learn a lot from the experts we have in the room. But let me have an idea of how many people. If you can hear us and see us, please say hi. Let us know if you guys are able to see us and hear us. I see Louis, I see Mary. I don't know if those are the only people we have currently, but I mean, I'm assuming that they can hear us. So maybe I'll allow our experts to introduce themselves, and then I mean we can go direct to the questions so that we save on time, because I feel like we have so many questions from the machine learning team, and I'm going to bombard you with all these questions. So yeah, just say a little bit of hello, who you are again, what you do, and then I'll take it over and continue.
Okay, I guess I'll go first. Hi everyone, I'm Carla Abdul Hakim, and I'm currently the founder of Diverse K. So at Diverse K, we're matching diverse tech talents to recruiters. So it's a community of tech professionals, enthusiasts, and recruiters. And you're invited to join. But before that, I had a background in machine learning research and still very passionate about machine learning. Currently, I'm looking at the application of machine learning to the field of education, and that's a brief intro about me.
All right.
All right, cool.
Um, yeah, please, Yinka, go
Oh,
ahead.
all right, sure. My name is Alayinka Peter Olafemi. I I currently work at Verify as senior machine learning engineer, where I lead a dedicated team of data scientists and engineers to particularly build and deploy machine learning models. Right. So we heavily utilize TensorFlow for model building, and just recently. TF7 and TFX for pipelines and evaluation and monitoring and all that stuff. I also became the recently became a gold developer expert for machine learning, which is a really huge opportunity for me to further engage the community and speak more about TensorFlow and stuff, and yeah, share cool stuff with you guys. So yeah, nice to meet everyone.
All right. Thank you so much, Yinka and Kaulat, for letting us know more about yourselves. And like I said, we're really looking forward to learning from you. And I'm going to just go straight into asking questions so that we like save on time. And I think there's always this notion, and I'm going to start from that particular point. There's this notion like, oh, okay, maybe I want to get into machine learning, and I'm like, maybe I didn't learn math in school, and I'm like, do I need, okay, people learn math in school. Maybe I was not really good at math, and maybe I'm afraid of, okay, is mathematics, and programming really important for me, so that I can get into the machine learning space, or even without this, can I still get to, understand machine learning concepts and become a machine learning engineer. So I want you guys maybe to like touch on that. How important is mathematics and programming knowledge in machine learning? And probably share what skills, do we need to develop, especially if we are beginners in this machine learning field. What skills do we need to learn? Or what skills will help us become um, great machine learning engineers, or rather just succeed in this field? So I don't know who wants to go first. Is it Kaulad or Yinka? Okay, Yinka's mic is on already.
I was going to say Carla should go first, but okay, yeah. Okay, so for the question, I mean, I feel like the question that a lot of people tend to ask, and it turns out that in some way, maybe it does not even matter if you're probably good at math or not. I like to think of myself as one who's not good at math, right? But you know, pretty much figure stuff out, right? So I feel like, compared to every other thing, right, in comparison, it turns out that um, the fundamentals of what makes up, computer science is mathematics, right? And usually when you are equipped with some kind of fundamental, it like helps you in regards of whatever career. When you're equipped with some fundamentals, it helps you, you know, um, um, at whatever point you find yourself in that career. So I'd say yes, mathematics is a really strong tool to have in your toolbox. At the same time, if you think that you struggle with math, I want to assure you that not all of what machine learning is math. A lot of libraries have been able to create a layer above the maths of machine learning, right? So you can write, you can build cool stuff without doing the maths part of it, right? If you're exactly not confident about your math background. So again, it may not matter. It just probably depend on whatever um, stuff you're trying to build, right? So a good example is if you are doing stuff that related to computer vision, for instance. So say um, you're maybe doing some Pydantic stuff and you need to build custom algorithms for computer vision, then you most certainly will require math because you want to, open up, you know, deeper layers of whatever the current algorithm is, and then modify the algorithm and stuff. But if you wanted to work on something more related to NLP, in the field of NLP, even though it seems as though there's not been a lot of advancement, right? However, there's been a lot of libraries in the past few years that has enhanced the possibilities in NLP, and so you probably won't need math stuff, right? You just can utilize libraries and build amazing stuff, right? So again, I'd say it may matter, but most certainly you don't want it to be a bottleneck. Don't let it stop you. If you're passionate about machine learning, then go for it. Right. Yeah. So
Okay, to add to that, I would say it depends, right? You have to look at your own personal strengths. Machine learning is very broad, so you can choose to be very good at one part of it. So you can decide to focus on, I want to be very good at training models and making them accurate. Or if you have a software engineering background, you can focus on, I want to be able to put these models in production. So you just have to look at what are your strengths. Mathematics is heavily needed if you want to go into the research side of things, because that's where you'll be working with more of the base algorithms. So that's where you need more maths. But if you're in model training, you probably need to know how to code more and train models and twerk parameters better. And if you're in trying to focus on deploying models, you can focus your own career in that side of things and be very good at the software engineering and DevOps side of things. So you just have to look at your strengths and what you want to do. And once you have that your own main thing that you want to base in, you can always just explore and continuously learn. The most important thing as a machine learning engineer, or somebody interested in machine learning, is to learn continuously. You can't it can't just happen. You can't know everything at once. So understand the basics very well. The basics are the most important thing. And then look at your strengths and focus on one side of things and grow there, then you can now expand.
All right. I mean, thank you so much to the both of you for those elaborative, answers on math. It's good to know that, okay, at least now I know I don't really have to be so good in math. I mean, Yinka is a GTE and it's not really good, like according to him. So it's good to know that we can always choose what areas to focus on. And yeah, I hope this really answer some of the questions that some of us are really wanting to get into machine learning. And yeah, so I think let's talk about, application areas of machine learning, because I think there are people that maybe have heard about machine learning and some have not heard about machine learning, or maybe maybe these guys are using some real world example of machine learning applications, but they really have no idea that machine learning is involved. So I'd like you guys to maybe talk about what are some of the existing and exciting applications of machine learning today, especially in Africa, and how can we even get involved in some of these areas?
I mean, these days that response is not hard because there's ChatGPT, there's everything that everyone knows now, and machine learning is not just this like secluded and secret thing that's just a few people know about. Almost everyone can see the application now. So look at ChatGPT. You know, machine learning is heavily used there. There's an integration of natural language processing and some reinforcement learning and some generative models that apply to like building a system like that that can generate languages and also respond to languages just like we would as humans. So that's a very, very interesting application of machine learning that we can see in our everyday use. And another simple one that I'll add, if you use Gmail, that way, when you're writing and it auto completes for you, that's another application of machine learning. And another aspect of natural language processing. It sort of predicts what it is you want to say. So there are tons. I'll let Yinka give more examples.
Well, I mean, I feel like you've already covered it. I think these are very excellent examples. I didn't even think that far myself. I was so struggling to think of examples. But yeah, yeah. You mentioned Gmail is a very good mention. ChatGPT is an amazing mention. I mean, excellent progress from the OpenAI team for ChatGPT, right? I mean, a couple of other examples I will use. Snapchat, for instance, is able to identify where your face is, to know where to put the filter, all those things. It's a product of machine learning as well. So yeah.
All right. While we're still on this, the ChatGPT mention, that leads me to like another question that I have, and I'm just asking this just in case we have, additional things to add, or maybe want to focus on what impact these things are. So my question is, so what are some of the, exciting or new developments, in machine learning, and what impact do you see them or expect them to have in the future? I'm asking this because I know you've mentioned that. Yeah.
Okay, so I'll say that for ChatGPT, for instance, an impact that is likely to have in the future is very and I feel like I can't even put into words. But so think of cases where you need to perhaps I'm so sorry about the noise in my background. Um, in the office and this I'm sorry. Right. So for ChatGPT, for instance, so think of cases where you probably need to explain something to someone, or you probably need to um, maybe make a computation by yourself, um, or maybe suggest something for someone, right? And in this case, um, you've got like an assistant that can do all that for you. So, for instance, you can have an assistant that is able to. They can just say, "Hey, remind me of all of the things I forgot to do yesterday." Right? All of the things I forgot to do yesterday, and then you can, just pull up a list and say, "Oh, this is what I forgot yesterday." So simply because that assistant is it's probably recording all your conversations, all your phone calls, all your every single place you probably visit. If you got something somewhere, if you were supposed to fix your car tire, if you were supposed to um, maybe update or fill up your grocery list again, or your fridge, whatever, right? It's able to list that stuff. And then because of the fact that as humans, we cannot take record of, we can't remember, yeah, that's right. Because we can't remember everything that went yesterday. We have to think through, right? You just say, oh, give me a list of all the things I should do today from yesterday. And then you have a list um, of stuff that you should do today based off all your day's activities the previous day, because it has taken all your conversations from the previous day into cognizance, right? So that's a really powerful assistant that's going to make us as human beings way more productive in the next few years. So, and even saying in the next few years is far fetched. I mean, some of you guys can already build that. What I just said now, you can build it with the power of ChatGPT. You can already build something like that, right? So imagine that kind of possibility into every other system, into every other thing, anything you can think of. The possibilities are, those are endless, So yeah, I don't know if that works, but yeah.
Yeah, talking about impact, I'm going to cite an example from a research I worked on that involved self-driving cars, autonomous vehicles. So something we can anticipate is the future where, you know, self-driving cars are a thing on roads. Maybe not Nigeria soon, but a future where the same way ChatGPT just came and disrupted things, there would just be that change of things to self-driving cars. It's already happening with Tesla, but it's still for the rich people and for a certain number of people. But there could be a future where it becomes the norm. So that's another example.
All right. I mean, that's good to know, and we are here for it. We're looking forward to seeing some of these things and even the impact they're going to have even in our lives. I'm even seeing people having conversations around, oh my God, is this going to affect some people's jobs and things like that? And I mean, a lot of interesting things are happening. So I'd like us to switch gears and let's go back to like getting started. So, what would you say are the important concept that you feel like everybody needs to understand when you are getting into machine learning, and how do you even get around them? So let's look at people like I'm just getting into machine learning. What do you think I really need to learn for me to even thrive in this field, and how can I even go about doing this? Yeah,
Okay.
let's start.
Okay. Yeah, so like I said before, the basics is the most important thing. When I talk about basics, you have to first look at, okay, machine learning is very broad. You want to first understand, okay, this is the part of machine learning that I find the most interesting. So then you now need to look at, okay, these are the things required in this particular field, and what you want to do, which is the most important thing, is to start from the end to the beginning. So let me explain. What I mean by the end is go to job postings, even though you know that you are like not there yet. Go to job postings for that role that you envision yourself getting into in the future. So look at what the requirements are that are listed there. That makes you stay relevant with what is exact and learn what is most important in the industry today. So looking at just those job postings, you'll be able to see, okay, oh yeah, I need to learn Python. It looks like Python is something that all these companies are looking for as a machine learning engineer. Or I need to be able to use this particular framework. Is it TensorFlow? I need to know how to use TensorFlow. Or what are the things I need to know about TensorFlow to apply to this particular sector that I want to focus on? All of those things. And once you've gathered all the things that you need to learn, you now begin your learning process. Again, here's another. I want to invite you to the Diverse K community, because we're like building learning and study groups where you can even like understand what your skill gaps are and exactly what to learn. So the most important part again is the research. Don't just dive in and say, oh, machine learning, and you just go and type machine learning in Google, and you're going to see tons of books and courses and everything, and you'll just be very confused as a newbie. So follow that format of like looking at the job posting first, researching and understanding what exactly interests you, and then moving for ahead from there.
Thank you. Do you want to add anything, Yinka?
Yeah, well, yes, maybe I'll probably just mention that, for people who want to, start off, um, so if you already have a bit of background in computer programming, I mean, you can like maybe write basic, like you can write um, code. It's much, easier, because then what's probably left is, basic paradigms, theoretical stuff, um, understanding what frameworks are there, what types of problems machine learning is already out to solve, and then begin to you can still like pick one, right? But then if you probably don't have a background in programming yet, and you probably are still trying to learn to code and stuff, you probably want to first focus on acquiring coding skills, right? Or if you want to go the route of a data scientist, you most certainly also want to acquire basic Python skills, SQL skills, and then you so like build from there or grow from there. So there are a couple of courses on Udacity, Udemy, couple of study groups like Carla mentioned. If you want to try out, the opportunities she's offering as well. There's also Google road to becoming a machine learning developer, right? It's on the Google developer group, you know, website, and it's free. It lists a couple of resources that self-taught, right? The idea is that you sit down with your computer and then you teach yourself, and then at the end of that, that particular path, you know you're equipped with the knowledge that makes you competitive for machine learning roles, right, in the industry. So yeah, you can just take any of those courses.
All right. I mean, what I'm getting there is, I mean, researching, and I mean, the whole idea of looking for problems, and also, being equipped. So now let's talk about after equipping yourself with this machine learning knowledge. So, I mean, I would like the two of you to try and help us understand how can we start applying, machine learning to real world problems, and if you guys have any examples or projects that you can cite that are beginner friendly that people can work on, please go ahead and share that as well. And yeah, so how do we start to apply machine learning to real world problems? I mean, as a way of practicing the skills that we have learned.
Okay. So how do we start applying machine learning to real world problems?
Few places you can go. One very popular one is Kaggle. So Kaggle hosts competitions, and if you also just want to learn personally, you can just download the data set and work with it, and you can sign up for, or you can sign up for a competition, where you work with people to like win prizes. So that's one good one I would recommend for beginners in terms of getting reward experience. What do you think, Inka?
Yes, certainly. I mean, I was going to mention Kaggle as well. And Kaggle is like the bedrock for real life um, experience or exposure, right? So, because what you also see apart from data sets on Kaggle, you also see people's work on those data sets. You can see a good example is let's say you find a real life um, say breast cancer data set, right? Apart from that, you'll also see work that other people have done on that data set, and then you can read through their code, see how they loaded up the data set, how they cleaned it, how they performed some data science stuff on the data set, and how they built a machine learning model, and how the model now predicts or infers, right? Right. So yeah, I think that can be like a great mention to start up in terms of real world exposure. So applying machine learning.
All right. Thank you so much for that. And I'm already seeing people saying that Kaggle is user friendly and things like that. And so let's have a little bit of a discussion. And I don't know, I'm really curious to know what you guys have to say about this. But what are some of the most common misconceptions about machine learning, and how do you address them?
Okay,
Guys,
do you want to go first, Carla?
No, go first. You're the
Okay.
machine learning engineer.
Oh, oh, okay. So for misconceptions about machine learning, I think that one is a lot of persons, try to think of a machine learning engineer as just try to think of machine learning. So machine learning is a little bit different from it's a little bit different from data science, right? Even though the foundation, seems like it's the same thing. So I know that, in a lot of courses, right, there's to try to teach data science and machine learning like together. However, my understanding of what what this misconception is that whereas data science comes from a need to solve business problems, right? Data science comes from a need to solve um, to provide analysis, usually descriptive kind of analysis for to solve business problems, to help a business make better decisions in terms of data and stuff. Machine learning on the other hand is a field in artificial intelligence, which is a subfield in computer science, right? So data science in itself is not exactly a field in artificial intelligence, but machine learning is. So data science encompasses um, um, business objectives and analytics, whereas machine learning may or may not have anything to do with analytics, but would have more to do with mathematical um, algorithms with respect to learning from data and all that stuff. So I feel like there's that fine line, that distinct between the both, and in the same vein, one could put them under the same umbrella, right? Because they our you know our our libraries and our tools are the same thing. So what used to solve data science problems are almost the same thing what used to solve machine learning problems. But yeah, um, the the I feel like the mathematical background is different. So that's one misconception that I know. I don't know if you know any about that.
Oh, yeah. So, one major misconception is that you have to have a computer science degree or, some very technical degree like that. So, I interviewed three interesting people on the Diverse K podcast sometime last year. So, I interviewed Chris Alban, who is the current director of machine learning at Wikimedia Foundation. I also interviewed Madhu Govind. She's a current machine learning engineer at a startup called Clary, and Luis Serrano. He's also he's previously worked at Google as a machine learning engineer, and he's currently working at a company called Zapata Computing in Toronto. So the interesting thing from speaking to these three really amazing people who are high up there in their machine learning engineering careers is that they have very unique and distinct background. For Luis, he has a background in mathematics. So he actually has a background in mathematics up to PhD level. All mathematics until he during his PhD he decided he realized that machine learning was an interesting way to solve some mathematical problems, and he transitioned. And in the case of Chris Alban too, his background wasn't in machine learning or computer science at all. Madhu also had a background in backend engineering, and she transitioned within her current company by taking up projects from the machine learning engineering team. So, there are just different ways you can transition. The most important thing is learning and making sure that you are keeping track of what you're learning, understanding the basics properly, and then yeah, you get to the point you want to get. So that's one main misconception. So whatever point it is you are now that you feel you can't get started or you don't have like those things that you need to have is not true. You can always learn them, and um sort of gather all your toolkits.
All right. I mean, thank you so much for that. Personally, for me, I think every time, I mean, I've always had a keen interest in machine learning, but then sometimes I see maybe if it's a boot camp or I don't know, any program machine learning related. And then sometimes you want to apply and then you see something around, oh, you must have a background in Python. And I'm like, okay, this is not for me because I'm like, I really haven't learned this. I don't know if that's a misconception that I have in my head that I need to know this before I can apply. And sometimes I think there's a Google course in machine learning somewhere in the website. I don't know where, but I know it's there. And I was going through it and I was like, can I really do this? I just saw one of the prerequisites and I was like,
Oh my god, you remind me of something. When I was just starting out my machine learning career, I came across the Google machine learning crash course. I can never forget that course. That course, I was like, okay, the way this thing is super technical. If I know everything in this course, I'm going to become a badass machine learning engineer. But that's not the case. Like knowing like all the super advanced stuff is not really the way to go. So you want to like start with the basics. Once you're solid with the basics, the good thing is you can always like build on it on for specific problems, and that even makes you a better engineer.
Yeah, yeah, yeah. I think what I'm even really getting a lot from this session is the whole idea of researching, because you go at one site, see something, it's very hard, and you're like, you know what, this machine learning thing is not for me. And we start building misconceptions around, the whole thing for ourselves, and then they really stop us. I'm talking about myself because I know I always want to learn. Then in between, I'm like, okay, can I? This seems too technical. Am I really going to get it? And the whole math thing, do I need to know? So I think researching and knowing exactly, and I think maybe for beginners, that is what most people usually struggle with. You don't know exactly where to start from, or where do I look out? Like which resource, if I look at it, I know it's really gonna guide me, with the basic things, and know where to specialize in, and know
Yeah.
things like that. I don't know.
So
I
I've
feel
actually I've actually done that research for anyone who wants to get started. I have a course titled Transitioning to Machine Learning Engineering. And in this course, I literally break down everything that you need to transition to machine learning engineering, the data science skills that you need, the machine learning skills, or the software engineering skills that you need, the specific tools you need to learn and everything. So you can check out the course. It's titled Transitioning into Machine Learning Engineering. It's on LinkedIn Learning. So once you just search it on LinkedIn Learning, you find it there. And if you're somebody who wants to go down the data science route too, I have another course titled Inside the Mind of an Aspiring Data Scientist. So the idea behind that course was it was more like a journey through how I got into data science and what was in my mind, all the misconceptions, all the struggles of finding different things and not knowing what exactly works. So I basically talked through that journey and how I was able to finally find the right things to learn, and I recommended them in that course. So yeah, you should definitely check it out, whether you want to go via data science or machine learning engineering. These are two resources that you should you should check out.
All right. I mean, thank you so much for highlighting those. I hope everyone has taken note of them. I have taken note in my head. I mean, especially when you said you have broken down everything for us. Thank you so much. I feel so proud for having aired my concerns and my struggles. Let's go a little bit technical, not really technical, but the machine learning concepts. And I know, like, there are some words that really come to mind whenever we speak about machine learning, and even models. We talk about accuracy, we talk about bias and things like that. So how do you ensure that machine learning models are accurate and biased, and what tools or techniques do you use to ensure this?
Well, so typically for to ensure accuracy from the onset, you want to, well, depending on the problem again, you want to ensure that you have as broad enough data as possible. So, a good example is, I mean, let's assume that you are doing some type of supervised learning, right? Where for your for the data in question, there are labels already, right? Let me let me cite an example of um, trying to trying to classify transactions, for instance. So you're trying to classify, new transactions. You're trying to say, oh, for each type of transaction, what is the label, right? So a good example is you send money to someone, and in the description you write, food money, right? Um, you are trying to now build a machine learning model that is able to classify that transaction to say, oh, this transaction is a food expenditure transaction, right? Another kind of label might be for utility. Right? So, say you pay for your subscription or your NEPA bill or your water utility, or another label could be maybe transport. So you pay for Uber. Another label could be medical bills, right? So you pay for a drug or you pay for a doctor's appointment, right? So stuff like that, right? So let's assume that you already have um, um, a list of transactions on the labels. Now, the first thing to try to do to attain accuracy or to reduce the likelihood of inaccuracy is you want to have as broad enough data as possible. So for each label, let's say There are like 20 different labels, right? So for those 20 different labels, you want to ascertain that the transactions that are labeled, you know, each of those labels are like they have like the same number of transactions. So for food, for instance, there are like 100 transactions that are labeled as food. For medical bills, they're like only transactions that no transactions are labeled as medical bills, right? That they're like that they're the same, right? Not that one is like 5 transactions under one label, and then there's another one like 270 transactions under one label, right? So um, there has to be that, so like uniformity, because that's where if there's a bit of bias in data, then the model is going to bias as well. Right? If there's a bit of bias in data, it's going to be bias. So accuracy starts from the data itself. Accuracy starts from the data. Right? You don't. So you cannot. One can expect the model to be accurate if the data with which it has learned is not accurate. Right? So I feel that that's like the first thing to think about. So, in very very broad machine learning teams, there's usually teams that they call them the data collection team. And then there's another team that they call the data scientists or the machine learning science team, right? So the guys that collect data are the ones that try to ensure that those data are very fine and uniform for the machine learning science team or the decision science team. So they'll build models. Then there's now the machine learning ops team that takes those models or build pipelines for those models and put them to production and monitor deployment and all that stuff, right? So I'm just trying to talk about the importance of that first data collection team or data preparation team, right? That, you know, the first process is important for the accuracy of the entire model. So it works, everything just works fine. So it's easier to then, run, or it's easier to like fine tune hyperparameters. It's easier to play and test your model when the data is good enough. So that's one way to start with. I feel like I said a lot, but yeah, I mean that helps.
Yeah, I'm just going to add onto what you discussed. The points you mentioned are like really great, and they're like the key things. So, in addition to having your data to be accurate, which is the most important part, as Yinka said, there are some other important concepts during model training that you want to be very, very careful of. So there's a term called overfitting. So that is when you overtrain your sample data, and then you have this high accuracy of almost 100%, but then when you deploy that model to prediction, it does very poorly. It doesn't predict properly. So what's overfitting here means that you've trained your model and have been too concentrated on that particular data that anything outside that data is foreign to the model. So that is one tricky part. Then there's another term called feature engineering. So imagine you're training a machine learning model to be able to predict maybe the future weather of in Nigeria next week Monday, and you are using data that is completely irrelevant to that training. So you're trying to predict weather, and you're looking at the age of the people in the country. They don't correlate. So you need to make sure that you select the features that are very particular to the results that you're trying to get. So selecting the right features is another key thing. Then making sure that you don't overtrain the sample data. So those are like broad descriptions of those two.
All right. Thank you so much. I'm almost done with the questions from my side. I mean, I have one last question, but I'm not sure. I feel like you guys have talked about it, but I'll just ask it again just in case there is something that, I may be assuming, but you guys are the experts, you know better. So I'll just ask it. But, before I ask it, I would like our audience, if you guys have your questions, I mean, we can start taking them. We have a few minutes, like let's say 4 minutes before we wrap up. Maybe we can take one or two of your questions. And I mean, we see that you guys are learning a lot from this, and we appreciate it. And yeah, or maybe Mark can help me put some of these questions live. So the last question that I was meant to ask you, and I feel like you guys have already talked about it, is I mean, how do you approach selecting and preparing data for machine learning projects, and what are some of the best practices? I know you guys. I feel like you guys have touched a bit on that, but if there's something that you feel like you should add and it's very important, please go ahead and do so.
So sorry, just to get the question. The question is, how do you approach data? What are the best practices?
Yeah, how do you
Right.
approach selecting and preparing data for machine learning projects, and what are some of the best practices to follow?
Well, that's a very amazing question. Um, but again, it usually would depend on the problem. So, for instance, um, a lot of the problems that we want to solve already have data. Some of these problems even already have pre-trained models, right? So you probably, so a good example is let's say you want to train a computer vision model to identify dogs, right? And then you wanted to identify your own custom dog. So let's assume you have a puppy, and your puppy's name is Frederick, right? You say, Frederick, come here, right? And then you've got this small door that leads into your house, and only Frederick should be able to pass through that door. Other, I mean, once that door sees Frederick through a computer vision camera, it can recognize Frederick, and Frederick can come in. And then you don't want anything else, say a cat, Frederick's friend, any other dog, right? So now there are already put-in models that can identify dogs. So the first thing you start from is, can your computer model, can your machine learning model even identify a dog? And differentiate a dog from a human being, right? So you want to try to, get data that differentiates a labels a dog and other kind of objects, right? So human beings, vehicles, whatever. Now my point is that there's probably already a picture model that can identify what a dog is, right? Maybe you want to use that picture model. Now you now want to improve on that model and train that already picture model with your own dog, Frederick. So you want to take pictures of Frederick, right, from different angles, different different things. So by the side, by the face, ensure that it shows have color, ensure that like say 200 different pictures of Frederick, and then you train that model that already can recognize dogs, right, with your new data of Frederick. So the model can now recognize Frederick from other objects, from anything it sees, you can know that this is Frederick, right? So um, a good approach or a better approach to solve that kind of problem is to use pretend models, pre-trained models, and then build, your model on top of that pretend model, right? Another example would be, let's assume you wanted to, um, build a model that would, maybe I should use the same example I used for the breast cancer thing, right? You particularly want to maybe meet hospitals and ask them for their scans um, of maybe breast cancer, if they can release it, or you probably want to check cargo for the data sets, or you want to check open source data sets across the web, and there are 1,001 of them. It's very interesting. It's very exciting how much the internet is, you know as a lot of data to equip you to solve the problems that you want to solve, right? So I don't know if that helps. Or Carla has anything to add.
Oh, I think you covered it all.
Okay, thank you.
All right, thank you so much, Yinka. I mean, I thought that we're gonna have time to take in questions from the audience, but I mean, in respect to time and the agenda that we are trying to follow, we may have to, wrap up this particular session. But I think it will be. I mean, I've seen some of the questions here, guys. things to do with data science and machine learning. And I think Yinka really talked about this in the beginning and the whole question about maths. He really talks about them. So once this recording is available, you guys can watch over again to just hear what he said about that, even for the areas of AI. So you guys ask things that he has talked about. But then again, Yinka and Carlat, I think it would be nice if you guys share your social media, handles or profiles so that people can really follow up with you with questions. Because I know they really have questions to ask and they can't. So yeah, if we get your handles, that would be fine so that people can easily follow up with you guys and we can continue with this particular event. Yeah.
Okay, on Twitter, you can find me at Diverse Kaulat. And on LinkedIn, you can just search my full name, Kaulat Abdul Hakim. Um, and also on YouTube, you can follow the Diverse K YouTube channel. I interview tech professionals every Friday. So you can always be part of that conversation.
All right. All right. Yeah, thank you for putting it up on your profile so it's easy for people to see. I don't know if Yinka is trying to do the same, but anyway, yeah. Uh,
Okay, let me try to do the same.
yeah. But
So
thank you
it's
so much.
just
Thank you so much for sharing. We've really learned a lot, and I really hope the audience has learned a lot. I wish I could ask you guys telling us yes or no, but personally, I have learned a lot, and I believe everyone has learned a lot here. And we'll definitely go and check out the courses you shared, Khalad. And I think every time I see diverse, I'll just remember you, so I can just go and search diverse. And
Yeah, I can see one more question in the chat. Someone asking how can you join the program? So you can just visit diversek.com. All the information you need is there.
okay, okay. That's fine. So thank you so much, guys. We need to go back, to the main agenda of today. So thank you to our speakers for sharing your knowledge with us, and we look forward to learning more from you guys. Go and disturb them in their DMs or
Thank you
tag.
so much, Tabitha.
Yeah,
all right.
yeah.
Thanks so much,
All
Tabitha.
right.
All
Bye
right,
All right,
bye.
bye.
bye. Bye.